Hi, good morning. I'm going to go over questions 5 through 8 today because number 7, actually I'm going 5 through 7 today because number 7 is so long. So we're going to try to make this as quick as possible for you guys, but just bear with me. I do want you to learn from it and understand it. I've got a lot of shadow going on this morning, so if you see shadow, sorry about that. All right, so number 5 is pretty easy. I think a lot of you are really comfortable with this. We're writing the linear function to model the world problem. So we're trying to write this. A linear function means we're trying to write this in y equals mx plus b form. So we're trying to make it look like a line, the function for a line, the equation of a line. So number 5, water is being pumped into a pool at a constant rate of 8.25 gallons per minute. So 8.25 gallons per minute is our rate. Remember, rate is just another word for slope. If the pool contained 1,250 gallons of water initially, so this is what we're starting with. So that would be our y-intercept. Write a function for the number of gallons of water, g of t, in the pool after t minutes of pumping pool into the water. So this one should seem pretty straightforward. G of t is how they want us to write it. And it equals what you start with, 1,250, plus 8.25 times t, because it's 8.25 gallons per minute, and t is the number of minutes in the problem. Now, to make it look, this is a correct answer, by the way. To make it look like a linear equation, of course, we always want slope and the variable first, and we always want the y-intercept last. So that would be the answer to that one. The next learning target is I can write linear functions in a variety of forms, and it asks you to write the equation of a line that is parallel to 2y minus x equals 16 and passes through the point negative 6, 1. There are a couple of things I've marked on here that are extremely important. Number 1, we want something parallel. That means that it has to have the same slope. Remember, if two lines are parallel, they have the same slope. That's important. Also, it's important the point that it's going to go through, negative 6, 1. All right? So the very first thing we have to do, if we know that our new line has the same slope as our old line, well, then the first thing we need to do is find the slope of that original line. So the way we find the slope is to put it in slope-intercept form. In other words, solve for y. So if we look, we're solving for y first, right? So we just start with our initial equation right here, and we start to solve for y. So we're going to add x to move it to the other side, and then we're going to divide all of the items by 2, and then we end up with our equation in y equals mx plus b form. And then we want to make it a little simpler, actually, because we also want to, if we write x over 2, we want to make sure we remember that that's the same as 1/2 x. And so 1/2 is our slope. Well, if 1/2 is the slope of that line, then that's the slope we need to use to find our new equation. Okay, so let's just retrace for a second. Remember that all we've done is take our original equation and we've solved it for y. That's all we've done. We found our slope. So now we're going to put that into slope-intercept form using our point, because the new line has to have that slope and has to go through that point. So we say y, which is 1, equal m, which is 1/2, times x, which is negative 6, plus b. Now we're just going to solve for b so we can write the equation this way, where there's no y and x in it. All right, so what's 1/2 times negative 6? Well, it's negative 3. So that gives us 1 equal negative 3 plus b. Then we're solving for b, so we add 3 to both sides, and we get b equal 4. Now we're just going to write that into the equation, and we have y equal 1/2 x plus 4. Okay, so again, you're solving for the slope, because you need that slope. And then after you solve for the slope, then you need to use that slope and your point to find the equation of your new line. All right. let's look at the next one. This is the last one we're going to do today because it is an entire sheet of paper. But these, I think you'll remember when we get started. I just know that you did really well with this overall, but it takes so much time. So that's why we're only doing 3 problems today, because we're going to be able to zoom through the rest of this pretty quickly. Remember, when we have a system of equation that has 3 variables and 3 equations, it just takes a little bit longer than the 2 that you did in Algebra 1. So when we do this, we're going to want to use that elimination method. Remember, we can graph to find where they cross. You can use elimination. You can use substitution. But for when we have 3 and 3, we usually use substitution. So I'm going to put the other paper with the answers on it up. And we're going to talk through this because, again, it's a lot. See the preview? It's a lot. All right, but it's not hard. It's just very time consuming. All right, so we're going to start with 2 of the first equations. So if you look at your paper, this was the first equation, and let me make sure I'm saying that right. Yep, and this was the original second equation right here. Now, our whole point in elimination is to eliminate or get rid of one of those variables. Well, the easiest variable to get rid of is z, because if I just multiply this bottom equation by a -2, then, 2 and -2 will cancel out, and that's what we want. So I'm going to rewrite my first equation. That is the exact same equation. I'm just rewriting it. And then I'm going to multiply my second equation by -2. So -2 times -3x is 6x. -2 times 2y is -4y. -2 times z is -2z. And -2 times 27 is -54. Now, once I've done that, the goal was to drop this z out completely. And you can see that they do cancel out. So we're just going to add them. So 2x plus 6x is 8x. 3y minus 4y is -1y. The z's cancel. And 14 and -54 is -40. So we're going to just circle that for a second. We're not done, but we need to get this back. We're going to need to come back to that right there. All right, so we're going to go sideways, and we're going to do exactly the same thing. So you'll notice that the first equation, we're using it again. And now this equation on your paper was originally the third equation. Okay, so we did the first one and the second one. Now we're doing the first one and the third one. It doesn't matter which 2 you use. It just matters that they cancel easily. What I like about this one, if I use the first one and the third equation, it's a really nice way to cancel the z's in this case. Because once we cancel z's here, we have to cancel z's here. You have to cancel the same variable in each one. So the way I'm going to cancel is if I take that first equation and I multiply by 2, that'll give me a 4z, and it will cancel with the -4z of that third equation. Okay, I know this is a lot. So if you need to pause and rewind, definitely feel like you can do that. All right, so now we're going to multiply the first equation through by 2, which is this. We just talked it through the first time. So you're just distributing that 2 to everything. Then we're going to copy the second equation. We're just copying it down. Again, I'm sorry about the shadows everywhere. And then we're going to add them. So 4 plus 4 is 8x. This adds to be 11y. The z's cancel just like we wanted them to. And 28 and 28 is 56. So now we have 2 equations with 2 variables. And this is much easier because this is what you did in Algebra 1 and earlier in the year when we reviewed it in Algebra 2. So what are we going to do with that? Well, we're going to take those 2 equations and we're going to use them, and we're going to use elimination method again. So we're going to just write the first equation, which is this one. And we're going to write the second equation, which is this one. Now, you can see that they both have an 8. So if I just multiply the second one, either one actually, but I chose the second one. If you choose that, you can multiply through by -1, and our 8s are going to cancel. So I'm copying my first equation exactly as it is. Then the second equation, I'm multiplying through by a -1, which basically just changes every sign. 8x is -8x, Positive 11 is negative 11. Positive 56 becomes negative 56. All right. I want to try to speed this up because I know we're getting a little long, but these are going to cancel. Negative 1 and negative 11 is negative 12. These add to be negative 96. When we divide by negative 12, we get y equal 8. Well, so far, this is awesome because we have one of our three variables. Now, all I need to do is plug the variables in and solve, and we're done. So we've done all the hard part. We're going to take this 8. We're going to go back to one of those equations right there that we got the 8 from. One of these two, which are these right here. And I chose this one because it's just smaller numbers. So I'm going to put 8 where y is. So it's 8x minus y, which is 8, equal negative 40. So then we're going to add 8 to both sides and divide by 8 and get negative 4. Well, now this is awesome. We know that x is negative 4 and y is 8. That means we can take these two and plug it into any of our three original equations from that very first page. Any of these three original equations that you have listed on the front page. I chose the very first one. So I now know this is my original equation with x, y, and z in it. I know my x is negative 4, so I'm going to plug it in there. I know my y is 8, so I'm going to plug it in there. And now I'm literally just solving for z. So this is an easy equation for you guys. So 2 times negative 4 is negative 8. 3 times 8 is 24, plus 2z equal 14. When we combine our like terms, we get this one. And then we have to start solving. So we're going to subtract 16 and get 2z equal negative 2. We're going to divide by 2 and get z as negative 1. So our final answer, and you have to put it in x, y, z order, or you can just tell me, you can just circle that, and I know that you have all three answers right here. But this is the way we tend to write it, negative 4, 8, negative 1. All right, well, I hope that rings a bell. We're going to be doing a lot of review at the end of this year to get you ready for next year, and just to make sure you have a really solid foundation in Algebra 2. We're going to pick up with our next video at number 8 and be able to roll through quite a few because 2 of the future ones need a graphing calculator. So we're just going to be able to skip those because I don't have one and I don't know how many of you have one. All right, see you later.